On this segment of cuisenaire rods, I'm going to be talking about how we can use them to discuss the ideas and concepts around fractions. In the multiplication section, we talked about factor families, and so what we're going to be talking about now is using those factor families to talk about some of the relationships between the pieces and the numbers. So if we start off with a purple rod, we might say something like, how many red rods does it take to make a purple rod? And that would be 2. And we could write the sentence for that something like this. So 2 reds equal a purple. And so from there we can say if 2 reds is equal to a purple, then 1 red is what part of a purple? And we come up with the idea of 1/2. And it can be written something like 1 red is equal to 1/2 purple. Now some students would say, well, if the purple is twice as big as the red, then the red is twice as small as the purple. And twice as small, if we're talking about smaller things, we might use that phrasing to get to the idea of a fraction or a piece of the whole. Continuing on, we might use the white blocks then, and it would look something like this. And we can come up with a statement: 4 whites is the same or makes 1 purple. And conversely, we can say 1 white is equal to 1/4 purple. So we can tie in the relationship between whites and reds and purples, and we can talk about our factors. If red, which is 2, is a factor of 4, and white is a factor of 4, then we should be able to have some kind of a relationship written either in this whole number way or using a fraction way of writing that relationship. Often when we're working with fractions and teaching fractions to students, we use something that's always the same size 1, either a fraction circle or the hexagon in the pattern blocks, or a fraction strip, which is always the same length. These ones have different lengths, so our 1 whole keeps changing. So using that same technique we just talked about, if we use our brown, we ask the students to find all the numbers or all the rods that are related to that, which is another way of saying what are all the factors of that, and we're going to come up with this set of relationships. And these would be our relationships as far as our rods go. And to write that down, we could write the following things for each one of these. 2 purples is equal to 1 brown, 4 reds is equal to 1 brown, or 8 whites is equal to 1 brown. So we're now looking for the matching statement or equation that's going to talk about how it works in the other direction. If 2 purples equals 1 brown, then 1 purple is equal to how many browns? And we get to the idea of 1/2. 1 purple is 1/2 of a brown. 1 red is 1/4 or 1/4 of a brown. And again, getting the idea of fourths and quarters, there's a lot of language there that you have to work with. And so you might want to come up with one and stick with it instead of converting back and forth to each of them, whichever way you might want to do that. And then 1 white is equal to or makes 1/8 of a brown. 1/8 of a brown is the same or makes 1 white, or is equivalent to, or equal to. All those words can be used and discussed, and all those kind of ideas can be put up on a word wall so that students are understanding that equivalent and equal and makes is the same as all mean the same thing. And so you might want to have that on your word wall as part of your number talks and discussions around the language that you're using in your classroom, as well as the discussions that you're using with the teacher in the grade previous to yours and the grade after yours, so that you're all using the same phrasing and the same words so that students are aware of what it is that you're talking about. It's quite common for a student to say, oh, well, I don't understand what that means, and then you say it in a different way. They go, oh, well, then why didn't you say it like that? So as long as everybody's using the same phrasing and the same words, it makes it much easier for students to understand a concept. Fractions are difficult enough for many students anyway, and we keep changing the words for them. So if we keep the words the same, maybe we can make the fraction concepts a little easier to understand. From here you can work on all sorts of different families. We have the family of the 6s, the families of the 9s, and the families of the 10s. We notice that in every single example that we've done, we can break it down into the smallest one are going to be our whites, and so 1 of whatever, the number of whites is going to equal the original block or rod that we have, and that's going to give us our 1 whatever, 1/10, 1/9, 1/6, 1/8. Those kinds of ideas, those are our building blocks, our smallest pieces, and we're going to put everything relative to that. We can make our discussions around our factors, our factor families that we were discussing when we were talking about our multiplication. And our multiplication using the cuisenaire rods ties in nicely here with the fractions that we're talking about with the cuisenaire rods. From there you can move on to activities something like this. Give them a blank that looks something like this. They'll have to put it in a brown and then fill it in with the blocks, and then have them fill out a chart that looks something like this with the following different equations on it. So 1/2 of a brown is equal to a purple. So there it is there. 1/2 of a brown is equal to a purple. 1/4 of a brown is equal to that would be a red, and 2/4. So which ones are the quarters? Well, the reds are the quarters, so 2/4 is equal to what piece? What would we call that? So 2/4 of a brown. So 2 reds is, in other words, you could write 2 reds. You could write 1/2 n. So a variety of ways of writing these things out. Over on this side we have 1 white is equal to 1/8 of a brown. So what would 2 whites be in terms of a brown? What would 3 whites be in terms of a brown? And now we're getting into the idea of 2/8 and 3/8. And we can also then talk about 2 whites is equal to a brown. What part of a brown? Well, that would be 1/4 of a brown, or we could say 2/8 of a brown, or we could say that it's equal to a red. And now we can start introducing the idea of equivalency and equivalent fractions as well. So we can do activities along this line to get them thinking in both directions, smaller pieces to bigger pieces to smaller pieces, and how would we phrase those, and how would we write them. So with the blocks we can make fractions kind of make a little bit more sense. It also allows us to do some things that normal kinds of fraction blocks or fraction strips don't do. They tend to have the same size 1. Here we've used different sizes 1. We've used a dark green as a 1. We've used a blue, purple as a 1, we've used brown as a 1, we've talked about an orange as a 1. So when the 1 changes, we can still have fractions of them though. And we want to make sure that the students understand that if I know that there's 2 greens, make a dark green, then 1 green is called 1/2. And this number on the bottom talks about the number of pieces that it takes to make one of the big pieces up in my original piece. Down here I have 1 red is going to be 1/3 because it takes 3 pieces to make my whole. My whites are going to be called 1/6 because it takes 6 pieces to make a whole. And the same thing happens when we have this as my whole, except now instead of my green being 1/2, now my purple will be 1/2. This can be called 1/2 and this can be called 1/2 because it's relative to the size of my whole. And this allows students to understand fractions in a slightly different way than if we always use the same size circle blocks or the same times fraction strips or the same size 1 in the pattern blocks. Whatever it is that we're talking about, sometimes students don't understand that the 1/2ness can still be 1/2 even though my whole is a different size or a different shape. And cuisenaire rods allow us to do that. We can still get the idea that the number on the bottom, my denominator, tells me how many it takes to make my whole. It also gives me the idea of what the size is. As my number gets larger and larger and larger, my pieces get smaller and smaller and smaller because it takes more of them to fill up my whole. So all the concepts we talked about with the other fractions, in the other segments that I've talked about in fractions using the other manipulatives, can all be realized and shown with the cuisenaire rods as well.